Hello everybody. In this video I want to give you a demonstration of the horizontal coordinate system altitude and azimuth using a software called Stellarium, Stellarium, Stellarium. You can download it from stellarium.org. I'll put some links on Canvas. It's a free software if you're using the web version, the PC version, the Mac version, or the Linux version. There is an app version, but I believe they charge a little bit for that. But otherwise, it's a free software, extraordinarily powerful at simulating the night sky over a large range of times and everywhere on Earth, and even from different perspectives in the solar system if you want to push it that far. We won't be going that deep into it today, but I do want to introduce you to the program, and I would like to show you how we can use it to get a better view of the horizontal coordinate system. So you should be able to see my Stellarium up on screen. I'm gonna go to full screen mode. It's a little bit easier. And for altitude and azimuth, I always like to change the settings a little bit. So I'm gonna go to a perspective view, which will give us a nice flat horizon. I'm gonna make the stars a little bit brighter. And I'm gonna make it so there'll be slightly more labels on. All right, that should get the settings how I like them. So here we have just a view of the local sky. It's a picture of a horizon. This is supposed to be the location. We are here in Knoxville at 36 degrees north and 83, or really about 84 degrees west. So that is our lat long. Okay, so our horizon is the line that marks the land from the sky. And one of the other terms I introduced to you is what is called our meridian. That would be the line that would go from due north straight up through our zenith point that's directly overhead down to due south. So now we have our western part of the sky where you can see the sun. And we have our eastern part of the sky over here. Okay, so far so good. We have now seen the meridian projected up on the sky. But this is a video about coordinate systems. So here I have my bottom menu bar. You can see that I can bring up what Stellarium calls the azimuthal grid. That's our horizontal coordinates. And it has a button for equatorial coordinates as well, or equatorial grid. Let's take a look at the horizontal coordinates. So now it's projecting a grid of altitudes and azimuths on the sky. Let's go with the altitudes first. So that's how far up you're looking, and these are in degree increments of 5 degrees. So we have 5, 10, 15, 20, 25, so on and so forth degrees, all the way up to our zenith at 90 degrees. Come back down to our horizon here. So the altitude is just how high up, 0 to 90 degrees. We also have our azimuth. And remember, we define 0 degrees azimuth as north, and then increases toward the east, so going this direction. And each one of these lines, demarcations, is 5 degrees. So 5 degrees azimuth, 10, 15, so on and so forth. East will be at 90. South at 180. You can see the meridian going right through there. And west at 270, and going back to north would be to 0. And now we can actually start talking about how we can use this to locate objects in our sky. What object are we going to use? Well, let's go with the sun. Remember I said that the horizontal coordinates, altitude and azimuth, are good for a particular place at a particular time. It's the right here, right now. But it's extraordinarily easy to communicate. Because I could tell you, look just a little bit south of west and up about 30 degrees, and you'll find the sun. Okay, that's great. Let's actually put some numbers on there. A little bit of functionality. So I'm going to bring up the date and time. So now we can see that we're looking on August 31st, and the current time is about 5:30 p.m. And you can see the seconds are ticking away. So what is the altitude and azimuth of the sun? Here's west at 270, so 265, 260, 255. So that, what is that? That's about 257. So 257 degrees of azimuth. What's the altitude? This line right here is at the 30. So about 31 degrees altitude. So now we have our altitude and azimuth, about 31 degrees altitude and about 256, 57 degrees azimuth. That's all well and good. Nice. I told you where the sun is. However, we know that the sun likes to set in the west. So what I'm going to do is I'm going to speed up time. I can totally do that in Stellarium. I can be a master of time. So make it so we have about every second 1 minute is passing. And now we can actually see the sun moving in the sky. And notice that it's moving its way through altitude and azimuth. As it sets in the west, the altitude is decreasing and the azimuth is increasing. But it's constantly changing altitude and azimuth. Clearly, whenever you tell somebody a coordinate in altitude and azimuth, you also have to specify what time you're talking about, what day, and at what hour. You can see it changes pretty quickly. All right, as our sun is setting to the west, let's go on over to the east so we can watch the stars rise as night falls in the east. So here we are looking east, azimuth of 90 degrees. The sun is setting, and I'll speed up time just a little bit more. So now the sun will set, and no, there goes our moon, changing its altitude and azimuth. Has some radial points for meteor showers. Not very interesting to us at the moment. There's Mars, constantly changing its altitude and azimuth. Uranus, all these stars. The Pleiades, right here, Aldebaran, constantly changing their altitude and azimuth as our minutes and hours are ticking by. Here's Orion, and let me go ahead and bring us back to regular time. So I can show you that we can turn on our constellation lines and labels. So here's our constellation figure, Orion. And now I can speed up time again. We can say bye to our Orion as it continues to rise, increase in altitude and azimuth, as it makes its way towards the meridian. So let's go ahead and follow it. It's rising higher and higher as it goes towards the meridian. It's up in the daytime now, hits the meridian, and now it's going to be setting. It's getting lower in altitude after it crosses the meridian. And eventually it'll set in the west. All right, so what I'm going to do is I'm going to bring time back to running at regular speed, come back to right now, and I want to look to the east. So going back to the east, and I'm going to go to 10 p.m. tonight. So I could give you, say, the altitude and azimuth of, say, the moon, and you'd know exactly where to look at 10 p.m., or really 10:28 p.m. tonight. You'd look at azimuth about 141, altitude of about 26 degrees. And I could tell you where Fomalhaut is, but again, if we change time, those would be constantly changing. So you need to specify the time. You also have to specify the location. So notice where Fomalhaut is, pretty low in altitude, and where the moon is. And now I'm going to bring up our location window, and I'm going to send us down towards the equator. Fomalhaut is now higher in the sky, and the moon is higher in the sky. So different location on Earth at the equator, different altitude and azimuth, same time. So you have to specify the location that you are and the time that you are going to be looking if you use the horizontal coordinate system. Because the horizontal coordinate system is fixed to your local sky. Your local sky depends on your locale, where you are located. All right, so I just want to end this video with just a little bit more fun. Let's go to our North Pole. I'm going to do what's not recommended. I'm going to turn off our atmosphere. And that's because I don't want to see the day sky. So if I'm at the North Pole, what would be directly above my head? The North Celestial Pole. That's where Polaris is. So the zenith, at my zenith, at altitude 90, I should find Polaris. Oh, there it is. And everything should rotate as the Earth rotates around its axis. Everything should be rotating around that point. So let's go ahead and speed up time. Yep, everything's rotating around that point. And now, what would it look like if you went to the North Pole during polar night and watched the sky? Everything just sort of rotates around and around and around. Nothing's rising or setting. Everything's always up. All of these stars that we can see are circumpolar. Not really changing their altitude at all. There's Gemini right there. All right, so that was a little bit of a bonus teaser material, stuff for you to think about as I introduce the altitude and azimuth system, our horizontal coordinates, using Stellarium. I really do hope that you enjoyed this. I hope you download Stellarium, and I hope you play around with it. If you want any primers, this bottom bar is your best guide. Also, come see me during office hours, and I can teach you how to use this, and we can review a lot of the concepts as well. Thank you for tuning in, and I'll see you in the next video.